Hey everyone, welcome back. Let's launch the gizmo and pick the cylinder 3D from the gear menu. Then snap it to the side view and scale it along the Z-axis. Give it a little increase in size and unmask those two polys with the mask lasso brush. Extrude them with the gizmo and move them into place. Let's do the same for the two polys at the bottom. Unmask them with the mask lasso brush, extrude them with the gizmo, and move them into position. Now switch to the Move Infinite Depth brush to continue modifying the model. Since this particular piece has a bunch of repetitive steps, I want to take this chance to chat about some of ZBrush's cool features for hard surface modeling, even though we won't be using them in this course. Not to say these features aren't great, it's just they're like a special spice. I reserve them for very particular situations that happen not to pop up during this project. The first thing I want to talk about is Shadowbox. It's a really cool tool for hard surface modeling. For a quick summary, Shadowbox is one of those tools in your ZBrush toolbox that lets you go from a concept to a basic 3D form super fast. You just sketch out your design from three sides, the top, front, and side, and bam, you have a 3D model. It's almost like magic. What I particularly like about it is how intuitive it is. You don't need a deep dive into complex tutorials or have a degree in astrophysics to get it. You just sketch and let ZBrush do its thing. It's user-friendly enough for beginners in ZBrush and yet powerful enough for the experts. Another cool thing about Shadowbox is how it can help create intricate, complicated shapes. So let's say you're working on a hard surface model, like a fancy piece of machinery with lots of unique, intricate parts. Trying to model all those parts by hand can be tough, but with Shadowbox, you just sketch out the shapes and it creates the 3D form for you. Of course, it's not always perfect. One thing to remember is that while Shadowbox can get you started quickly, the resulting mesh isn't always the cleanest. So you might find yourself spending time cleaning up and refining things. But honestly, being able to generate complex shapes quickly gives you more time for adjusting and refining. Alright, now that we covered the basics, let's dig a little bit deeper into the Shadowbox magic. Shadowbox, which is tucked away in the tool palette, in the geometry menu just above the clay polish section, is more like a transformation rather than a standalone tool. This means you need to have a Polymesh 3D object selected before you can transform it into a shadow representation. And once you hit the Shadowbox button, the shadow of your object is projected onto three planes, and just like that, you've got yourself a mesh. But remember, the resolution you set before turning on Shadowbox influences how detailed your shadow projections will be. Now if you're just starting and you want to create a completely new shape, you're still going to need an object to start from. I suggest going for a simple primitive like the Polymesh 3D star just to get the ball rolling. After it's loaded, you can clear the converted mask from the Shadowbox walls and start creating your shape. And here's where the fun part begins. You get to use all the standard mask brushes to edit your shadow and bring your vision to life. But there is a catch you should keep in mind. Shadowbox is a bit like a one-way ticket. Once you activate it, your original 3D model morphs into its shadow version, and there's no going back. So if you're fond of your original model, I recommend cloning it before switching to Shadowbox. Another trick up your sleeve could be to load one of the Shadowbox projects found in Lightbox. But remember, doing so will clear out all the custom objects in your tool palette, so it's like starting with a clean slate. So all in all, Shadowbox is pretty awesome for hard surface modeling. It's quick, straightforward, and it can handle complex shapes, making it a tool worth getting familiar with. Another feature we really didn't touch on is panel loops. They are super useful for hard surface modeling. So picture this, you're working on a complex robotic design and you're struggling getting those intricate shapes just right. Well, panel loops might just be your new best friend. They let you whip up these shapes you probably lose your hair trying to get right with normal methods. Panel loops can often help you get rid of that muddy, wobbly look that often comes with sculpting. They create this effect of separate panels or pieces, making your model look less like a sculpted figure and more like a real mechanical piece. It's the kind of detail that draws your eye and keeps it there. Speaking of details, panel loops can create all sorts of nifty details like grooves and bevels. But perhaps one of the coolest things about panel loops is how that gets along with the rest of the ZBrush tools. They fit right into the workflow. You can use them alongside tools like Dynamesh or ZRemesher to get the most out of your modeling. Alright, let's dive a bit deeper into what panel loops are all about. Once again, panel loops in ZBrush are tucked away in the Tool Geometry subpalette. They're all about morphing your model into separate panels with their own thickness. What's cool is how they make use of the polygroups or the visible polygons on your model to define each panel. And just like that, you've got different surfaces to work with. Just a heads up though, panel loops work best with meshes that don't have subdivision levels. Once you've created your panel loops, ZBrush gets right to work assigning a unique polygroup for each loop based on your loop settings. It's a great help when you want to use that Polish by Feature slider for that extra touch of refinement. Now let's chat a little bit about the workflow for panel loops in ZBrush. It's really not that complicated, and it gives you the chance to experiment with a bunch of different configurations for your model. First off, you're going to want to establish multiple polygroups on your model. Each of these is going to turn into a different surface, each with its own distinct borders. Another approach is just to hide any polygons you don't want to include in the panel loops. Next, you want to navigate to Tool, Geometry, Edge Loop, and hunt down the panel loop section. In there, you'll find a polish slider with a little dot symbol. Give that dot a click to toggle it solid and then hit the panel loop button. Your model now should be divvied up into individual panels based on the polygroups or visible polygons. You'll notice these panels have borders with a thickness that are bridged together according to your settings in the panel loops section. Alright, let's go over some of the specific settings for panel loops. If it helps, you can navigate to the panel loop menu on your screen as we go over the settings. It can feel a bit technical, but don't worry, we'll go over it one by one. The loop slider is a handy little feature that allows you to set the number of polygon loops you want. If your bevel shape is intricate, then you'll need more loops. Just bear in mind that every additional loop increases your poly count. Then there's double mode. When on, it makes panels with both front and back surfaces. When you turn double off, you get panels created as bevel sections on the original surface. Next up is the append setting. When you turn this on, ZBrush doesn't get rid of the original polygroup when panel loops is made. Then you've got inner mode. This makes panel loops inside the model instead of outside. Next is thickness, which sets the thickness of the panel and affects the distance between the panels. Then we've got polished. The polish slider smooths out the resulting mesh, especially the edges with polygroups, giving you those super clean edges. The bevel slider is pretty straightforward. It sets the size of the bevel between the polygroups. The bevel profile curve is what decides the shape of the bevel between the inside and outside surfaces of the panel. Then there's ignore groups. If you're doing a panel loop while only one part of the mesh is visible, this option lets you keep the current polygroups. This is handy if you want to create more panel pieces across a panel that already exists, and you don't want ZBrush to make panels for every polygroup. Lastly, the elevation slider is all about the height of the panel relative to the original surface. So you can decide if the panel will be raised above the surface or be sunken below it. So yeah, panel loops in ZBrush are pretty awesome. If you're a fan of hard surface modeling, you'll definitely want to include them in your toolkit. Another ZBrush feature I use every now and then is Spotlight 3D. So imagine you got this 2D alpha or black and white image and you're thinking, man, this would be cool if it was 3D. Well, that's exactly where Snapshot 3D jumps in. With just a click, it can transform your 2D alpha into tangible 3D objects that you can tinker with almost like magic. Let's say you're working on a robot or something mechanical and you need some intricate gear or machinery-like details. Snapshot 3D will take your 2D gear shape and transform it into a fully fledged 3D gear that you can adjust to fit perfectly onto your design. It gives you the ability to create intricate hard surface details with relative ease. And it's just not simple shapes. Even if you have a complex stencil, like a fancy Victorian keyhole or a Celtic knot, Snapshot can handle those too. It's as easy as creating the alpha or stencil, positioning it over your model, and hitting the Snapshot 3D button. Also, with its Boolean capabilities, you can use Spotlight 3D to create more complicated shapes by adding and subtracting simpler ones. So Snapshot 3D is an awesome tool that gives you the ability to quickly create intricate 3D shapes from 2D alphas, which can be super useful when trying to get those details just right. It's kind of like having a 3D printer inside ZBrush. So it's time to get back to the play-by-play. Let's do a bit of crease cleanup before we jump into the next section. Bring up the gizmo and select the cylinder 3D from the gear. Press Unify and set the H divides to 100. Let's snap it to the side view and scale it along the Z axis. Now hold down the control and move with the gizmo to duplicate. Rotate it 90 degrees and scale it down. Go ahead and give it another 5-degree rotation and move it into position. Hold Control and move with the gizmo for another duplicate. Let's rotate it 90 degrees and scale it up. Finally, let's make some adjustments to the position. Hold Control and move the gizmo again to duplicate. Now clear the mask and click Auto Groups. Unmask the cylinder and grab the Move Infinite Depth brush to rework the shape. Unmask the other cylinder and adjust the shape as well. Unmask the cylinder and Control Move with the gizmo to duplicate. Now we can scale and move it into place. Let's unmask the cylinder and scale it back. Unmask the top and scale that back as well. Next, unmask the top cylinder and reshape with the Move Infinite Depth brush. Let's unmask the cylinder and Control Move with the gizmo to duplicate. Go ahead and adjust its size and placement. Let's use the Move Infinite Depth brush to adjust the shape. Clear the mask and press QC50. Go ahead and set the smooth subdivision to 2 and hit apply. Delete the lower subdivisions and set the Dynamesh utility poly count to 1. Now we need to grab the clip curve brush to flatten the top. Next, we want to use the picker to set the resolution and dynamesh it. Go ahead and mask the model. Fire up the gizmo and from the gear, select Polycube. Invert the mask and split unmasked points. Now press Unify and delete loops. Let's scale it along the Z-axis. Then mask it and maneuver it into place with the gizmo. From the Z brush, add in an edge loop. Then Q-mesh the single poly. Now we can collapse the two edges. Go ahead and unmask the top points and rotate them. Now we can transpose the edge. Insert a single edge loop and move the edge back with the gizmo. Next, we want to press Ctrl W to group visible. Let's merge the subtool down and dynamesh. Unmask the poly group and grab the clip curve brush. We're going to want to unmask the poly group again. Mask everything except the front. We're going to use the Move Infinite Depth brush to move it down and dynamesh. Once that's done, clean it up with the planer brush. We'll run a polish, then mask the model. Bring up the gizmo and from the gear, pick the Polycube. Invert the mask and split unmasked points. Press Unify and delete loops. Let's go ahead and scale and move it into place. Next, we want to hold Control and move with the gizmo to duplicate. Next, merge the subtool down. Let's isolate the cubes and hit Group as Dynamesh Sub. Bring up the gizmo and from the gear, select Remesh by Union. Once that's done, navigate back to the gear and click Accept to lock it in. Next, we'll use the planer brush to do some cleanup. Unmask the top cut and move it down a bit. Now we'll run a polish.